Hello everyone, we are GroupT and today we'll introduce the paper Mask RCN, which is the base paper in ICCV in 2017. First of all, is introduction. Before that, we need to look at some tasks of facial visualization and object detection. In this image, you can see it can locate the bounding yellow box and classify objects. And then let's see the figure 2, and it's a semantic segmentation, which can achieve exact pixel and pixel and classify objects in this image. Finally, look at the figure 3. On the basis of this segmentation, instance segmentation perform the finer segmentation of the similar objects, such as a person 1, person 2. Mask RCN is an instance segmentation algorithm that can be used for instance segmentation, bounding box object detection, and the person key point detection. What Mask RCN can do? Mask RCN is a flexible framework that can aid different branches to complete different tasks. Now we will enter the Mask RCN paper analysis part. First, I will introduce the whole algorithm steps. Step 1. Enter a pre-processed image and input it into a pre-trained neural network to obtain the corresponding future maps. And step 2, set a predetermined ROI for each point in this future map, thereby obtaining the multi-candidate ROIs. Step 3, use some strengthened models to filter out some candidate ROIs. Step 4, perform a ROI align operation on these remaining ROIs. And finally, use the FCN operations are performed in each ROI. We post the Mask RCN into 3 models: Fast RCN, ROI Align, and FCN. Then we will explain the 3 models respectively, which is also the core of the algorithm. Firstly, I will introduce the Fast RCN. You can see that the framework of the RCN series for target detection obtains the 4K models, including the region proposal and filter extraction and classification, and the regression, maybe it's ROI regression. However, the Fast RCN uses a neural network to combine the 4 models and train an end-to-end network. It aids a branch to Fast RCN that output a binary mask. And also we can see the main contribution of the Mask RCN is analyzing the disadvantage of ROI polling and the proposed ROI align, improving the effect of detection and instance segmentation. The biggest difference is that the former uses 2 quantization operations, while the latter does not use the quantization operation and use a binary interpretation algorithms. The ROIs use 4 sampling point in each point and computing the value of each sampling point by binary interpolation from the nearby grid points on the future map.
The next step of the Mask RCN is a semantic segmentation by using FCN, fully convolutional networks. Looking at this graph, each cube represents a convolution. Between each cube, there is a pooling step. At the end, upsampling is done by deconvolution. So what is convolution and pooling? Let me briefly introduce. First, convolution. Given an input signal sequence and a filter, the output convolution is this. This is the calculation result. Pooling. There are 3 kinds of poolings, and this is an example of max pooling. This is the result of max pooling. Next, loss function of the Mask RCN. It has 3 parts, and L mask is the newly added part. The first 2 parts are similarly as Fast RCN. How to calculate L mask? First, predict the k-cans of n multiply n binary mask output by mask branch. Secondly, according to the prediction results of the Fast RCN branch, the object type of the current array is I. The next binary mask output is the loss mask of the array. Next, let's come to result analysis. First, quantitatively. Array aligning can improve the performance of target detection greatly. According to this table, The results show that RN increases the AP value of mask by 10.5 percentage points, and the AP value of box by 9.5 percentage points. According to this table, we know that mask RCN uses two branches to decouple the classification and the mask generation, and then uses binary loss instead of multiple loss to estimate the computation between different types of masks. The output mask depends on the category label predicted by the classification branch. So the mask branch doesn't need to be reclassified, which improves the performance. From this table, we can see that mask RCN can not only save a lot of memory space, but also accelerate the whole training process. This is the instant segmentation results. This is the object detection results. From these two tables, we can see that mask RCN have really better results than faster RCN. Next, let's do some qualitative analysis. First, on this graph, we can see that mask RCN detect a person as disconnected objects. In this graph, we can see that mask RCN can detect really small objects, like this. This is human pose estimation results. Mask RCN can detect the different poses of people. However, there are some failure cases. This is a missing. This is another missing. Another failure is that mask RCN recognize this as a cat, however it is not.
The third part is a demo presentation. I will show you how to train the mask RCN model step by step to a new real-life application to detect spellings. So, what we want to do? We want to give detailed instructions on how to use mask RCN and how to apply it into real-life application. We train the model to detect spellings only, as you can see on the top right picture. And then we use the generated mask to keep balance in color while changing the rest of the image to grayscale. The implementation steps are: firstly, copy the source code into Google Drive and set up environment. Secondly, prepare data including training set and validation set. Thirdly, train the model. Finally, inspecting the results including data and model. Visualize training results and apply the color splash effect. For the environment setup step, we should download the mask RCN source code and upload it to Google Drive. You can create your own folder, but remember the path of these files because they will be used later. Then set the runtime tab to TPU and mount the code lab to the location of your source file. For data preparation step, you first need to label the training set and validation set. Create a new folder to store training and validation data. Here I named my balloon. And then create two new folders named train and val, and put the training set pictures and corresponding JSON file into the train folder, validation set pictures and corresponding JSON file into the val folder. Since I used the dataset provided by the author, the data is labeled, so if you need to use your own dataset, you can refer to this URL and do the label by yourself. Let's move on to model training. Use Python command line to run the train command. Here, I specify that the dataset is from Google Drive and set the weights. It's not enough to pass the dataset in the neutral network once. We need to pass the dataset in the same neutral network multiple times, so just using one approach is not enough. As we can see in the training output, step loss decreases with approach increase. After training, we can find training results in the log folder. Each approach generates a corresponding weight file. Next, we can check the training results. Firstly, we can inspect and visualize data loading and pre-processing code. It loads the dataset and visualizes mask border and the entry to verify that the size of the entry first fits the target size. Inspect Balloon Model notebook shows the result generated by the trained model. Check out this notebook for more visualization options. Here, you can view the detection process step by step. Finally, let's apply them to the color splash effect. The principle of implementation is very simple. Since our program can already recognize balloons, create a new grayscale version of the image, and then copy the color pixels of the original image in the target mask area, this image shows the end result of color splash.